Alright, hello my geometry friends. Today we're taking two things we know about the coordinate plane and things we've learned about triangle, and we're putting them all together in one lesson. So the first thing we want to do is review the midpoint in the coordinate plane. Now if you remember, we find the midpoint between two coordinates. In this case we'll call x1, y1, x2, y2. So the midpoint of my x coordinate would be the average of my x's, and the midpoint of my y coordinate would be the average of my y's. Alright, so that's a review of our formulas. Now let's put them to use. So, in the first one it says find the midpoints of the triangle. So essentially we're going to find the midpoints of all three sides. So let's start with segment A and B. So segment AB, and we'll start with x. So I have my x's, it doesn't matter which order you put them in. And I have x1 plus x2 divided by 2 gives me negative 10 over 2 or negative 5. And then I have my y's, which is here and here. y1 plus y2 over 2 gives me 1/2. So my midpoint would be negative 5 comma 1/2. Alright, and that kind of makes sense in context of my x and y axis. Negative 5 is this way, 1/2 is up a little. Alright, now let's do BC. So segment BC, we're finding the midpoint. I'm going to keep my x1, y1 there and change this to x2, y2. So the midpoint of my x would be negative 4 plus 8 over 2, which gives me 2. And the midpoint of my y would be 6 plus 3 over 2, which gives me 9 over 2, or 9/2. We can just leave it like that. 2 comma 9/2, which is the 4.5. That looks about right. And then lastly, we have AC. So I have x plus x over 2, which gives me 1. And I have y plus y over 2, gives me negative 1. So negative 1 comma 1. I'm sorry, positive 1 comma negative 1. Again, makes sense. 1's here, negative 1's down here. Alright, so that's finding midpoints. Now, you might think that's easy, that's just a review of what we've done, but over here, if you notice, it says list the midpoints of the triangles, but now we're dealing with variables. Alright, so it's a little different in how we treat this. So again, let's start with AB. Now, the process is exactly the same. We're using the same formula. So let's say x1, y1, x2, y2. So the midpoint of my x coordinate is 0 plus h over 2. Well, 0 plus h is just h over 2. Now let's look at my y's. I get 4k plus 0 over 2, which gives me 4k over 2, which is just 2k. So again, we just throw a variable in there. Don't get freaked out. It's the same process. So the midpoint between A and B is h over 2 comma 2k. Now let's go over to BC. Alright, so again we could go x2, y2 if it helps you with the formula. So the x is 0 plus 2h over 2. Gives me 2h over 2, which is just 1h. And my y gives me 4k plus 2k over 2. Well, 4k and 2k are like terms, so I can go 6k over 2, which gives me 3k. So my coordinate there is h comma 3k. And then lastly, we have AC. So my x coordinates are h plus 2h over 2, which gives me 3h over 2, which is fine. And then lastly, my y is 0 plus 2k over 2, which is 2k over 2, which is just 1k. So my final coordinate is 3h over 2 comma k. So again, just in more general terms, be comfortable working with those variables. Alright, and just as we found midpoint, we had other problems in chapter 1 where we found the endpoint. Okay, and if you remember, sometimes we did the formula, but sometimes we used what we called our jump methods. So what we said is, how much did we get to go from 0 to negative 3? Well, we went down 3 So to go down 3 again would give me negative 6. Alright, because 0 to negative 3 is down 3 from negative 3 is negative 6. Now for B, I went from 0 to negative 2, which is down 2. Alright, so down 2 from negative 2 would be negative 4 as my y coordinate. Alright, now this is a little different as we apply it to variables in a sense that we're not adding plus and minuses. Now notice we were going negative and we were in quadrant 3. Alright, so in quadrant 3 both coordinates are always negative, and we went in depth in that in chapter 3. So looking at this in quadrant 1, both should be positive. So let's think about this. From 0 to h I went up h. So what's up 1h from h is 2h. Alright, because up 1h from h already is 2h. So from 0 to 2k, I went up 2k. So what's 2k plus 2k? Well, up 2k more would be 4k. Alright, so same idea with numbers, it's just now we have variables. Alright, so that's everything we're going to do with midpoint. Now moving to distance formula. If you recall the distance formula from chapter 1, we have x2 minus x1 squared plus y2 minus y1 squared. Now, I do x2, x1. If you flip them, that's fine as long as you're consistent. You're just subtracting your x coordinates and in the same order subtracting your y coordinates. Alright, square them so they're positive, add them, and take the square root. So let's apply that to triangles now. So it says, what is the length of each segment indicated? So we want AC, AB, and CB. So we'll start with AC, so I have x1, y1, x2, y2. So the distance of AC is, sorry, just want to get my notation right, is the square root of x minus x squared plus y minus y squared. And that is a 4, not a y. Alright, so when we do our math, 5 minus 0 is 5. Negative 4 squared. So I get 25 plus 16, which is the square root of 41. Now let's just leave it as that for now. We can't simplify it, but you could get a decimal. Now it wants AB. So AB is here. Now with horizontal and vertical lines, it's very easy to find the distance. We can just count. Our y coordinates, because we're going up and down, from 0 to 4 is 4. 0 to negative 4 is 4 more units, but when we're talking about distance, we're always talking about positives. So 4 and 4 give me 8. So that one was nice. And now let's find CB. So CB, we have the square root of x minus x squared plus y minus y squared. So we're going to go minus negative 4. So 0 minus negative 4 squared. So I get 5 squared plus positive 4 squared, which is 25 and 16. And something looks familiar. Alright, so that's the square root of 41. So then lastly it says, is ABC isosceles, and how do we know? Well, if we remember, isosceles means that we have two congruent sides, and in this case we prove that we have two sides congruent. So the solution would be explanation with support. So is it isosceles? Yes, because AC, segment AC is congruent to segment BC, and isosceles triangles have two congruent sides. Alright, so that's distance and midpoint in the coordinate plane, and you are ready to deal with triangles and variables and all this awesome stuff you got now. So see you later.